Meeting is being recorded. Good evening.
Hey, hi. Good evening. I hope. Okay, there's a first Zoom call for everyone here, but I see only three or four of us here. Yeah. So, do you folks have this quiz on the coming Saturday, Sunday, or is it over for you folks?
It's over for us.
Okay. Hi, how are you?
All good, thank you. We are from EPTP 18. Thank you so much. Yeah, you're from 17, 16.
I'm prehistoric from 13.
Oh, but really, thank you so much for doing
No
this.
worries, no worries. I'm just waiting for a few more minutes for others to join.
Absolutely.
Yeah,
Yeah.
good to put a face to the name. And where are you from?
I'm from Chennai. I'm an anesthesiologist. And
Wow.
don't ask me. Yeah.
No, you must have. I'm sure I'm not sure, but I think, but the doctors they do study statistics as part of.
Yeah, actually, it's very silly because I also happen to be an ex-faculty of AIMS, and I'm supposed to have done all of these things. But somehow I always used to do the research methodology, and I used to be very happy collecting data and leaving the statistics to everybody. Now I'm just kicking myself for doing that.
Yeah, because it's a very integral part of what you do typically day in and day out kind of a thing. Yeah.
Yeah.
So where are you in Chennai?
So I work for Apollo. I had the simulation center for Apollo in Vanagaram.
Okay. Uh, that's not the green stored one. That's a different one.
So I report my office is in Green Store,
Okay.
but the center is in Mumbai. It's a little complicated because all 70 hospitals of Apollo has only one simulation center. So we literally cater to all of the Apollos.
Okay. How about others? Where are they from? I mean, don't mind if you may want to just turn on the camera for a few minutes. At least I will get to put the faces to the names.
Hey, hi, hello.
Hi. So,
Hello.
so where are you from, Bruno?
So I am from Assam, but I am currently in Bangalore. So I work as a business head for a startup. I head their white collar business. So prior to that, so we started very small. We were 10, 15 people along with the founders, started the company, built it brick by brick for almost 6 years. Now we are a team of 400. I left in between. Now they've called me back to head the white collar business. So
Nice.
yeah,
Nice.
that's about me.
Nice. Which part of Assam are you from, and where are you in Bangalore?
I'm from Guwahati. In Bangalore, I'm in HSR layout.
Okay.
I have been in HSR for most of my life
Okay.
because I've been in Bangalore since 2009. So I just relocated to Gurgaon for 2 years. 2023 till 25. So last month I came back.
Nice. Okay. Oh,
Yeah.
so you have inhaled all the AQI smoke from Gurgaon, then come back to the
Yes, absolutely. My lungs are full of it. Tilaka might be able to help me.
No, she will put you to
Detox
sleep.
my
She will put you to sleep. I mean, you know. And the funny thing is, I was told by another anesthesiologist, one of my very dear friends, that how the body wakes up from it is still a mystery. So I'm not sure whether it is correct or not, but
No, it is absolutely. We still don't know the exact mechanism how we put people to sleep. I mean, though it's scientific, but
Yeah.
we still have a lot to find out.
Absolutely. So she can put you to sleep, and there is no guarantee that you'll come back from that.
No,
No, I'm just kidding. I'm just kidding. I'm just kidding. What about you, Subhajit? Where are you from?
I'm from West Bengal, so I have around 10 years of experience in consulting, and yeah, now I'm into the CPGP course,
Good, good.
balancing both the worlds.
And where are you presently in West Bengal?
In Durgapur, the place called
Durgapur, still sitting.
Near to Kolkata.
Yeah.
Yeah. So thanks for yeah.
Anup, where are you based out of?
Presently, I'm in Bhopal.
Okay, nice.
Yeah. Presently I'm in.
Anup, you're from Bhopal?
Sorry.
You're from Bhopal only, or?
No, I'm not from Bhopal. I've lived all over India while growing up, so I have lost the sense of any individual place. To answer the question, I just say my parents are from UP, but I've kind of lived in the east, in the south, in the west, and the north. So I've lived all over India while growing up, while doing my job. So I don't have a sense of belonging. And just
Can be India ka dialogue.
yeah. I mean, yeah, absolutely. That is how have always defined myself. I always say that if I were to stand in an election, I will always lose because everyone will claim that I'm an outsider for them. uh, well, I turn out to be the true Indian. We are only five of us. Let's get started because I don't want to waste time. Let others join while they join. The question is now, how many of you still have the? There is one Srinidhi. Srinidhi, I did not get introduced to you. If you don't mind, if it is okay with you. There are more people. Sorry, I did not see. There are too many people. Okay, give me. Yeah. Sorry, I was not able to see them. Now I can see them. Okay. Yeah, let me just put it as this way. This helps. All right. So let's get started. Just a quick show of hands who have their quiz in the coming weekend, because I will then, depending on how many people have that, I will either go this way or the other way. A show of hands, probably.
all of us are following the trauma that happened in the last quiz for us.
Okay, there is only one person.
Tilaka scored 10 on 10, by the way. Huh?
That's not the criteria. That's about how we feel while we give the exam.
So let's do one thing.
It was traumatic.
Yeah, I mean, I can understand. And I told so. Incidentally, I happened to see the PPTs of Professor Chauvin, and I have seen the PPT of Professor Kapil, and they are like the poles apart. They are world apart. Okay,
Yeah.
so someone who is going to give an exam or the quiz on this weekend will probably not get benefited by what Professor Chauvin has done. Professor Chauvin is very applied. You have to really apply your brain. Whereas what Professor Kapil has done is he has kept it to the very basics to teach a few concepts, right? Now, I was hoping that I would discuss a few topics, and then I would probably go through the slides to if there are any questions. But because we have not, I mean, like, typically the last 3 or 4 sessions we have had about 30-40 people, and right now there are only 12. So let me go in a different way. I will probably discuss the questions that Professor Shovan has asked so that it gives idea to the other folks also. And then if there are questions, I'll take them. Then meanwhile, more people will join and then we can look at the PPT and some concepts, right? How many of you have not attended any session? Show of hands of who those who have not attended any session so far with me. 1, 2, 3, 1, 2, and I see only 2 people. Okay. Am I audible to others? Are others there? I mean, like, are you folks there in the call? Or is it office on the side and this on the side? Okay. All right. Okay. So let me share my screen first and I will. And I will, what I will do is, because I was sent the questions in a different manner, let me try to put it this way. Okay. You can see my screen, right?
Yes, yes. Sir.
Yeah.
Okay. So one of the questions was this, and I'll put it here. And this, okay. So for this, the options given were like this. So I'm not going to, this is the answer given by the student. I'm not going to show you the right answer, but let's work out the problems, right? And what I would expect is that if you have any questions, you will ask me you will stop me, interrupt me and ask me the questions. And also I expect you to help me with solving the problem, right? Okay. The following box plot shows the credit card outstanding in dollars of customers with respect to the default status. So this is the box plot. And I hope you guys can read it. I'll just take it.
Yeah.
Okay. First of all, can someone tell me what does? Let's just consider the one on the left side. How do I read this box plot? Can someone tell me how to read this box plot?
Yeah, I think, yeah, go ahead.
No. Go ahead.
No worries. So I think there are 2 box plots. One is for the defaulters and one for the non-defaulters.
No, let's just
I think
concentrate on the left
side.
side. Let's just look at the left hand side and tell me what do you understand from this box plot? What can you infer?
I think the median lies at around,
Right skewed
it's right skewed data. There are
and outliers.
a lot of outliers, and the median lies maybe somewhere around 650, 700-ish.
Okay.
This doesn't.
Okay. Good observations, right? Now, sorry, go ahead. Whoever is speaking, please go ahead, continue.
So the Q1 is somewhere around 500. The Q3 is somewhere around 1100, and the minimum value is that is the minimum is 0, and the maximum is somewhere around 2200, and we have outliers beyond that.
Perfect. So this is the Q1, right? This is 25 percentile. Why is because it's zoomed out. Okay. This is median. Okay. Median is 50 percentile, right? This is Q3, quartile 3, and this is 75%, right? Do all of us understand what it means? Is there, I'm just assuming that all of you understand. If there is any question, any doubt, please stop. Okay. So having said this, now, what is interquartile range? How do we do the IQR? How do we find it?
Q3 minus
Q3
Q1.
minus
Q3
Q1.
minus Q1, absolutely. Okay. Now let's look at the options that are there. I'll just zoom out now. So the options it says, okay, sorry, I'll just check one more thing here so that we don't have to come back again and again. The Q3 here is around probably 1200, and Q1 is around 500. Median, as someone said, was around probably, let's assume it's 750, right? And
Yeah, around 700, 650, 700.
and this is for the other plot, for the defaulters, it is 2000 is the Q3 and 1500 is the Q1. So IQR for the first one is 1200 minus 500, which is 700 is the IQR, and here it is 500, the IQR. Okay. Now, the option says that 25% defaulters have credit card outstanding below 2000. So it says 25% defaulters have credit card outstanding below 2000 approximately. It's funny actually. I would probably ask Professor Shawan to correct the way he's put it. The reason is the statement is true actually. 25% are indeed this thing. What he meant to say was only 25% or thereabouts 25%, not more than 25%. And that is not true because 25 below 2000 is the upper range, and that is quartile 3. How many percentile population is below this? 75, right? So 75 is there. So this is not true in that sense. Credit card outstanding data for the defaulters is right skewed. Is this right skewed? This one, is this right skewed?
No, this is not.
It is not.
This seems like a bell curve.
Yes. With some outliers on the left side. Very few outliers on the left side. Okay, and then variation in the mid 50% outstanding. Okay, is that sorry? This is the one. Yeah, variation in the mid 50% outstanding data among defaulters is more than that of non-defaulter. Okay, so it says the variation in the mid 50%. What is the mid 50%? Mid 50% is the IQR. Right? Is more than that of non-defaulter. Okay, and is that true? We just calculate IQR 500 versus 700. Is that true?
No,
it is not.
It's not.
Right? And average credit outstanding among the non-defaulters is significantly lower than the same among the defaulters. Average credit card outstanding, which is actually true. Like if you see average credit card outstanding is much less than how can we say that? We can say that because we are talking about the mean value, not the median value now. Okay, but the biggest outlier here is 2500, and that is much less than the top value over here, right? And you can calculate the number of those. So it is the average mean value is also lower, which is actually true. Okay, so that is the correct answer. Then let me go to let's see.
No, I didn't get this part. When you mentioned that the outlier, so something I missed out maybe on that part.
Average credit card outstanding among the non-defaulters is significantly lower. Significantly lower than so average credit card outstanding is basically the mean value. It is not the median value. Right? And if you look at the data, that data is actually you see that data. How much of the population is around covered by till this point? Till this point,
75%.
75%, right? And till this part is probably about 25%, right? And then there are few outliers, 4 outliers. Okay. Now, yeah, and here this is 75%, and that mean that mean is much higher than this mean, right? And the remaining 25%, that mean is much higher than, I mean, not much higher, but that is also higher than these guys, right? So we can say the mean of this, the average of this is lower than the average of this. We can say that. Correct? Okay. It does not, how many people are there does not make a difference, because ultimately you're dividing by that. So is this part clear?
Yes, for me.
Okay. So I'll just, because I'm sorry, I use the software that helps me do some things very nicely and some things not so nicely. So, okay, this goes away now. So now, with this, let's look at the second problem that was there. Okay, this is very good problem, and this talks about correlation a bit. So consider the following scatter plot between the returns data from stock A and stock B. Stock A return, stock B return. Which of the following values of correlation coefficient describes strength of association in best manner? Some of you may have read correlation, some of you may not have read correlation. Correlation typically, okay, so the answer, sorry, I copied the answer. The actually answer is clearly minus 0.9. Why is it not any other? I'll explain you. Or does someone want to explain what correlation is, and then we can go there? Can someone give me an explanation? What is the correlation?
Correlation tells the strength and weakness between two, for the 2 points which is scattered on a plot.
Okay.
It has the relation and the.
And it has a relation. It has a range between +1, -1 to +1. If it is near to -1, it is strongly negative. If it is near to +1, then it's strongly positive. But if it is at 0, then it's no correlation.
Okay.
Or near to 0, then weak.
Okay. Anyone else?
It also shows a direction.
Good point. Okay.
So negative means that if one thing is increasing, the other one is decreasing. So in this particular case, if one stock is increasing, the other one is decreasing.
Absolutely. Fantastic. Okay, so what correlation actually does is it teaches now as this increases, if this increases, or if this increases and this decreases, or if this increases and this remains static, that is how two things move together, right? So there are 3 ways it can move. One is this is increasing, then the other is also increasing. The other is this is increasing and the other is decreasing. Third is this is increasing, but this is staying flat. So if your data is something, and I'm assuming 1 unit for each of this. So each of this is 1 unit. Okay, so that there is this, that for every 1 unit increase, probably it is increasing 1 unit, or this is good correlation. There's fantastic correlation, right? Now, if this is like this, the slope is very high. I mean, so if you understand what is slope, then slope is very high. But what is happening is the y is increasing tremendously, but the x is not increasing tremendously, right? So this, while it has a positive correlation, it is not very strongly correlated. Okay. Likewise, if the data is something like this, then x is increasing but y is not increasing, right? So this is basically static almost. So this is almost like a zero correlation. And the other way is x is increasing, so x is going in this direction, but y is decreasing. So y is starting from here, well, x is small, and then it kind of goes like this, and now x is increasing, but y is decreasing, and this is strongly negatively correlated. Now, what kind of graph do you see here in this one?
Negative. Decreasing.
Negative, right? So it is negatively correlated. So that is, yeah. So that is, oops. Yeah. All right. That is that. Then what's the next one?
I know one doubt
Yeah.
from the previous question.
Yeah.
So there are two negative values in the options.
1 second. Let me just put it back again. Yeah. Tell me.
So in the options, there are two negative. I think they are minus 0.2 and minus 0.9.
Yeah. That is there, and the reason why it is not minus 0.2 is because minus 0.2 would have been something like this is it is negatively correlated, but very weakly negatively correlated, right? So that means that this would have been a little bit flatter. The slope would have been a little lesser. Okay, it would have gone. It would have gone. It would have degraded slowly, like this. Okay, that would have made it a little lesser. Okay. Quick question: are you from Professor Chauvin's class?
Yes. I'm
Okay.
from
The reason I asked you is because Professor Chauvin has actually used a very good, where was this concept of this?
He has shared around 6-7 points on correlation.
Yes,
-1 plus.
So I'm just checking if it is in this one or the other one. It is not.
No, it is an EDA. EDA.
Exploratory data
Not
analysis.
here.
Okay, this one.
Not here. EDA related. EDA name.
Uh,
Yeah, this one.
it's correlation analysis, right? So these are strong relationships, and these are weak relationship, because for the same one you have multiple values. See the band. If you see the band, right, this will come back to you in regression analysis a lot. For the same value, you are having multiple. For the same x value, you are having multiple y values, right? So that makes it weak relationship. You cannot say here for one x value you have probably one y value, and it is going very almost, assuming that both are almost the units are same kind of a thing, right? So it is that. And then this is an example. This you will revisit probably if you are taking AI course, and you will revisit it in Professor what's his name? Forgot his name. Okay, never mind. So this is a R of 0.23. If you see, very small increase in x values gives you a very high increase in y values. Do you see that? It is going from 0 to 20 to 60. Whereas R is equal to 0.78. If you see, this is like from 0 to 100. Good values of good increase in R or sustained increase in R, x value gives you a sustained increase in the y value. Understand?
Right.
Okay.
Yeah.
Is this clear now?
Yeah, it's clear. Thank you.
So this is done, and there is now there is the other question. For this, my answer differed from Professor Shovan's answer, and I had to look at ChatGPT for the answer why it was different, and then I came to know. So, okay, before going into this, let me recall a concept, right? And we'll solve that, and then we'll come back to this example. What is Z-score? Anyone?
Standard deviation and mean divided by standard deviation, I think.
Okay, so mean divided by standard deviation. You're close, not exactly correct, but you're close. But what does it mean really? I mean, the question is, what does it really mean?
How far it is from the mean value.
Okay, that's fantastic. I mean, again, very, very close, but fantastically close. Okay. Now, before going to Z score, can someone share Gmeet, please? After if this, how much time limit is there? Sai Jyoti?
7 minutes.
If we drop off, please share a Gmeet already so that people will immediately jump because I'm recording, so it's all right. Just share it in the group. Shall we just drop off and then continue from there because we are starting a topic? Is this okay?
Yeah.
Let's jump to Gmeet. Is someone sharing it on Gmeet?
I'll share a link. One second.
Yeah, please share and let's just jump to it. I'm dropping from here. Okay, sometimes it allows me to change my background and sometimes it does not. I do not know why. Never mind. I don't like this background. Okay, so let me share my screen. So I asked what is Z-score and there were some answers given. Now I'll actually go further and I'll ask what is the standard deviation.
Just now I just recalled my notes. Shall I tell as I have already?
Yeah, go ahead. No worries. Yeah, absolutely. Let it be more as interactive as possible.
So in Z score, what we do, we take the standard deviation 1, 2, and 3. So how far it is from which standard deviation it is belonging to. So if it is far than 3 deviation, then it is outliers. That is what we get from this.
Okay.
That's what.
Yeah. So we'll revisit some of those concepts very soon. Now, can someone tell me help me understand what is standard deviation? What does it really mean?
With that, we can understand from from mode how much data is spread. So it has a 3 vertical standard deviation +1, +2, and -1, -2. So most of the data will come into the mid of those +1 and +2.
Okay. All right. So fine. What standard deviation tells you is how consistent you are. How consistent you are, right? That is what standard deviation tells you. Now there are two graphs I'm giving you, and let's assume they belong to the same units and everything is the same, right? They're comparable. This is one, and this is another. Okay. Those who are joining, sorry, I'll just take this call in a minute. Mommy, back meeting now. Okay, sorry about that. So which one has a better standard, which one has a lesser standard deviation?
Second one, because the data is like less scattered.
Yes. So this is more consistent. This has a bigger range and it is less consistent, right? So that is what standard deviation kind of gives you an idea whether you are more consistent or not. Now, what Z-score does is it lets you compare multiple things across different. I mean, like you have apples and oranges, and you want to compare them. So it brings you to that level. Now, for example, this is one of the examples. Please just pay attention to this part, right? I'm talking about 1973. Let's assume that in 1973, a person with 5 years experience was earning probably 4,000 rupees. Okay. In 2002, another person with 5 years experience was, let's say, earning 55,000. And in 2024, someone, let's say, with 5 years experience, well, let's assume that they were earning 1 lakh. Okay, what I've done is I've kind of kept it I got this data through these things from ChatGPT, how to get the mean income and the standard deviation. So how do you know which person was actually doing better for their times, right, in terms of earning the money? So what you say is you have probably for this guy was somewhere, let's say, he could have, that X could have been somewhere here, or it could have been somewhere here. We do not know. We have to find that out. Clearly the mean income is 1159 and that person's income is 4,000. So the guy would be somewhere here, right? And then 23,604 again. Let's assume that this is there's a second one. So mean is 23,604, and the person is earning 55,000. So probably again somewhere here, and likewise, this person may not do as well. Okay, even though it is 1 lakh, right? So we compare, and how do we compare? So what we say is we say x minus mu by sigma. I mean, depending if it's a population or if it's a sample, then it is x minus x bar by SD, right? Standard deviation, or S. So we calculate using that. So we will do 4,000. Someone please will have to help me with the values with the calculator. Minus 1159 divided by 669. This is, please someone do the calculation and give me the values. 55,000 minus 23,604 divided by 12,138. And this is 1 lakh minus 2,27,909 divided by 110,625. What's the value for the first one?
4.24.
4.24. Second one? Is someone calculating?
25.88.
25.88.
2.58. 2.58.
Okay. 2.58. Okay. And the last one?
1.16.
Minus, right?
Minus 6, sorry. Minus 1.6.
So you see, now we have, okay, first of all, let us understand the intuition behind this, right? What Z-score says is that how many standard deviations away you are, from the mean. Okay. X minus mu is how much away you are from the mean, and divided by sigma is how many standard deviations away you are from the mean. So someone who was earning 4,000 in 1973 was 4.24 standard deviations away, and you know the inequality, right? Most of the data, 99.99% of the data lies within 3 standard deviations, right?
Right.
So this person is really an outlier. I mean, absolute outlier, right? Phenomenally doing very well, right? Someone who earned 55,000 in 2002 with 5 years experience was in 2.58. Till 2 is considered normal. Between 2 and 3, it's not very normal. It's unusual, but all right. It's still in a good range. But 2.5 is fantastic range. You are in the top, in the last standard deviation, right? The last kind of 5%. And someone who is earning 1 lakh with 5 years experience now is actually doing, compared to these two folks, is doing pretty bad when it comes to earning money. They are in minus 1.16, which is on the left side of the mean. So this is how Z-score helps you compare different things, bring them on the same platform and compare them. Does it make sense? Did the idea become clear to you?
Yes.
Any questions on this one so far?
Sir, just
Anup, I don't like the word sir. Okay, please, go ahead. Anup.
yeah. And so, what is the value for 4,000 and 55,000 and 1 lakh?
This
How
is,
we will know which is better?
that's what we just did, right? So I'm assuming that a person X was earning 4,000 in 73.
No, I got the concept here. I got the formula as well. I am not getting where the last value for the 4,000, 55,000 and 1 lakh.
Last value meaning?
Formula value after the calculation. This 4,000 minus.
So it is 4.24. Someone calculated and told me 4.24 is the value for this particular thing.
Okay.
2.58 is for the second guy.
Okay.
And minus 1.16 is for the third guy.
Yeah. Okay. Now, so how we will know which one is better? Because it is in 2 are in positive, 1 is in negative.
So this is much better. This guy is earning much higher than the mean income.
Okay. That.
Okay. So this guy is earning 4 times the standard deviation, 4.24 times the standard deviation from the mean.
Okay. Now I got. Thanks.
Okay. So that is how you compare. So I hope it is clear to anyone else who has a question around this?
So the Z-score here, this was for salary, so the highest we were considering. So now if it was for a defaulter list or something like that, so we would consider with lower Z-score or we go with a higher Z-score.
I did not understand the question, but can you try to give some example with numbers and then I can tell you? I did not understand the gist of the question.
Suppose I'm taking a defaulter list of some credit card, like the previous example that we had. So defaulter list of credit holders. So if the Z-score of say the data of certain data samples shared by Chauvin sir is of Afro-Americans and Asians. So if I take a Z-score of those people, which one should be I consider better, the highest Z-score or lower Z-score?
Okay, so there are two parts to that. There are two parts for which I'll ask you questions. One is when you're saying Z score of there, so what are you, the Z score on what parameter are you talking about?
The credit rating.
The credit rating, the better the, okay, so that answers the second part of the question. The better the credit rating, the better the Z score would be. So you will take the higher Z score as favorable,
Okay.
right? I mean, if someone is defaulting on the loan, their credit rating would go down, right?
Yes.
Right. So if you want to compare them, and because you're comparing across on the credit rating, you don't have to really take the Z score. It's a direct comparison because you're talking about the credit rating directly.
Yes.
Right. I'll show you an example. For those of you who attended Professor Kapil's session, there is an example which is, let me see if it is in this one or this one. This conditional probability, probably here. Let me see. This is also Z. So I think it's here. Yeah. See this. Anisha graduated from IIT Delhi 10-point CGPA skill where the class average was 7 and the standard deviation was 1.5. And then she went to IMB and graduated from there 4-point CGPA with a class average of 2.8 and the standard deviation of 0.8. So now she has done from IIT Delhi and IMB with, and now someone wants to know where did she perform better? Because there is no direct comparison, there is no, we do not know how to compare the apples and oranges. So what we will do is, what's the CGPA in IIT Delhi? What's the X value?
8.
8, right? And in IIT Delhi, what was the mean?
7.
7. So 8 minus 7 divided by,
Standard deviation.
which is
1.5.
So we have 8 minus 7 divided by 1.5, which is 1 divided by 1.5. We'll park it. And then she got 3.2. So what's the mean for her IM class?
2.8.
So 3.2 minus 2.8 divided by
8. 0.8.
0.8. So 3.2 minus 2.8 is 0.4 divided by 0.8, 4 by 8, 1 by 2, 0.5. So one is 0.5 and the other is 1 by 1.5, which is 2 by 3. I mean, anyway, let's see what happens. Right. So one is coming to 0.67, the other is coming to 0.5. So where did she perform better?
IIT.
Yeah. Is this clear?
So
Yes.
just
So
one,
we
I
could-
got the
we could
point
have just-
here. Just one point here, how this standard deviation came into picture, because standard deviation for both is different. That's why it is.
And the reason is because standard deviation. Let me just take the other question also so that if I can answer both of them together. Someone else has had a question.
No question, but bro, I was studying we could have solved it with common formulas. First, for IIT, we could have get the average, like how much how much how much she has achieved. So here she got almost 80%, right? And in the second one, she achieved out of 4, she got 3.2. So it's around 78%, right? So I think by this also we can.
You also have to understand that, you might also want to understand what is the, you might want to keep in question. So what does standard deviation and what does mean give you is how did the class perform alongside her, right? Right?
Yeah,
And
yeah.
so that is what you have to take into picture, and that is where so this guy over here, I cannot make it here. I can just go here. IIT Delhi had a mean of 1.5, standard deviation of 1.5. That means IIT Delhi had a wider range, right? So IIT Delhi's graph would have looked something like I'm assuming this. So it would have looked something like this. And compared to this, the IIM Bangalore graph with a lower standard deviation would have looked.
So is it like in more population perform better? And, so this kind of understanding is correct.
In more population, not necessarily. We cannot say. I do not even know how many people are there. Right?
But sigma is representing that population, right? So
Sigma is not representing population. No. Sigma is representing just the fact that how much your data is consistent. How narrow this part is compared to this guy. So that is what sigma standard deviation represents. It does not tell you population, or it does not give you a sample size of the population size in those terms. So I do not know how many students were there. I mean, I could be in, just an example. Let's say in IIT Delhi, probably her batch size was 400, and in IIM Bangalore, let's say her batch size was, just assuming, 800. It doesn't really make a difference.
So Kapil sir slide in that we are not considering this which is outlier and all, because we are 4.26 sigma in the road, right?
Sorry, I did not get the question.
So in previous example which you put it, we get 4.26 sigma, which is more than 3 sigma. That is what we told at
Over here, 4.24, yeah. Yeah.
But in Kapil sir's example, we are well within the limit, right? 0.5 sigma and
Yeah, absolutely. We are well within the limit, but the higher the Z score is it tells you that you perform better than the other guy. Then not the other guy, but the other Z score. So 4.24 did better than 2.58, which did better than -1 point whatever it came to be, right? Z score tells you how. This is very important. Please understand that Z score is a ratio. Okay, so Z score, you are somewhere. You could be somewhere here. You could be somewhere here, and this person and the same girl who did in IIM Bangalore over here could be here in this one, or probably here. We do not know. We have to find out her being here is better than her being here with respect to this or not, is what we are trying to find out. And how do we find that? So we say this is your mean. We say this is your mean. Okay. So first tell me the difference between the mean and your position. And then that is how many standard deviations away from the mean. That is why we divide it by sigma. So the more you are away from the mean, on the positive side you are doing better actually, and the more you are away from the mean, on the negative side you are doing that much worse. Assuming positive is good and negative is bad. Does that make it clear, or is there some other question that I did not understand?
no, yeah, I'm good. So basically, mean value is like we need to consider it as a 0.
Because we at some point we assume that this is normally distributed and so on and so forth, right? So yes, sometimes the mean may not be 0. I mean, we make it so even if it is not mean, we shift it actually, and you do those transformations also. You will do the transformation, but it is very, very simple. You will get a table. I'm not sure whether you have been given a table by Professor Shoban or not. Have you been given the sheet for Z scores?
No, we have not.
Okay, so you will get that, and then you will see how do you shift it. How do you shift something? And basically, again, it means nothing else. What we are trying to say is this guy's mean was, for example, 1159. I'm taking the example of this particular. This was the mean income. Now, how do you, and the income was, say, 5,000 is what we said, right? And the standard deviation was 669. So 669 was the standard deviation. I should be using S if it is a sample population. Now, you may want to convert this into something with zero mean. So what you will do is you will push this by 1159 points, right? And then it becomes, you bring it to 0. The coordinate system, you move it to 0, and then it's again a normal, and then everything else applies. This is what we are doing actually. I don't want to confuse you with this thing, but this is what you will be doing when he gives you a z-score table and asks you to find certain bands and certain this thing. We will not go there right now. We'll go there in probably 2 or 3 classes from now. But does everyone get an idea of what z-score really does? Any questions so far? Go ahead, Manish. You have a question, I think.
No. Actually, I was looking for some.
Oh, okay, all right. Fine. So let's move ahead. Now that I have explained this part, we'll go back to the quiz question that was there, and why what I was missing. And okay, this is okay. I need to find a better day. Oh, I've used this example. I don't care for it now anymore. Okay, sorry. Let's see this. The question was this. The question is which stock performed better and why? And my initial initial thoughts from some of you. If you know the answer, fantastic. If you don't, try it.
So this answer is wrong for me. And what I interpreted at the time of the quiz, I compared mean, median, and standard deviation. So as per mean and median, because they are very near to each other, and standard deviation is also near to 1. So I was thinking it's consistent, and this should be the answer. That is what my assumption that time. I was not able to recall CV, correlation variation.
Yeah.
That coefficient variance. I was not able to recall that
Correlation
at that
variance.
time.
Yeah. So that is correct. I mean, I chose this because the standard deviation is lesser. Forget mean and median. The standard deviation is lesser. So that means this is more consistent. But there is a concept called CV, which basically is this divided by mean divided by standard deviation, I think, right?
Yeah, correct.
So 0.14 divided by 0.95, and how does it compare with 0.23 divided by 1.19? If you have not studied CV, I will not go into it because I believe there are other section folks also, and I want to concentrate also on some of the Professor Kapil's slides. So I will not go into that, but that's it. So you have to calculate CV for this one, and with CV, the thing is to the credit of the question paper, they had given the option of they had mentioned CV. And so you cannot ignore it. Had the CV not been mentioned, standard deviation less than this would have probably made sense. I mean, by itself. The next question is, yeah, this is a good question. We have covered this in multiple times. So let us see. Those of you some of you I know by the names have attended the previous sessions. So please tell me, please take a stab at it. If you know the answer, please do not, let others.
Anu, I have one query.
Yeah.
How we get to know that we have to calculate coefficient of variance?
It was actually given in the question, in the options. The reasons had mentioned CV.
Can you just show me once?
Yeah.
Yeah, it was related to CV on these items. So all the four options were given. One is CV
Here.
higher than something. Yeah.
So you had he had specifically mentioned for the Y as the lowest CV, highest CV, highest CV, lowest CV, and that's the reason why you have to go with that, and not the standard deviation. Yeah.
Yeah.
Good. Okay. So now, consider the following table showing the presence absence of a disease. And as I said, someone who has not attended previous sessions, or if you have attended but you do not recall it, take a stab at this one. Write down the answers to questions below. So, how likely is the test result incorrect? This is a fantastic business question. I want to understand how will you approach this question.
We calculated the false positives plus false negatives.
Okay, perfect. So you calculate something known as false positives and false negatives. Anyone else? What does it really mean?
So the disease is present, but it is showing as negative.
Okay,
And in the absence of the disease, it is showing as positive.
absolutely. So basically, what it means is your, whatever test you did, that result was not in line with the actual status, right? And so you have false positive. False positive is basically the test is showing positive, but you do not have the disease. And false negative is you are showing negative, but you have the disease. So present and positive. If the test is positive and the disease is present, do we have to consider this part?
No.
We have to consider
350 and 50.
perfect. So we have to consider 350 plus 50 divided by 5,000. Right? This is 400 by 5,000. Everyone understands this part? Are we good?
Why there is a summation? Why do we add both the things?
Because it is 350 is the people who got negative test result, but they had the disease, and you also, so this was false negative, and then you also have to take, so it is FP plus FN. These are the total sets. Before that, I'm not sure whether sorry, I mean, I don't want to make an assumption, but probability is what exactly? Probability of an event is favorable outcomes divided by total outcomes, right? Total outcomes is given by 5,000. Favorable outcomes is basically the test which tested negative, but actually the disease was present, and also the tests which were positive, but the disease was absent. So the total of these two, that's the reason why we are doing the total of these two. Does it make it clear?
But it can it be in such way also that 350 by 4850 plus 500 plus 50 by 150?
Oh, no. 350 by 4850 has got nothing to do with the fact that there are total number of patients are 5,000. So total number of outcomes you're taking from here. How many total patients were tested? So in probability, you will always take the total number of outcomes from how many patients were there. It may change depending on conditional probability, but right now we don't have the conditional probability part. So this is the total number of patients, not from this. From here, this is the total number of patients who have the disease. So if you say 4850, it is the total number of patients who have the disease. Now tell me something. Will this lot include the lot which has wherein the test was false positive?
No, they won't have.
Right? So you have to include this guy. This is what goes as the total outcomes.
Okay.
Yeah. So it is 400 by 5,000. Okay. Now,
If the question is how likely the results are correct, then we need to take.
how likely the test result? Okay, that's a fantastic question. So how likely the question is flipped? How likely is the test result correct? So what are the things that we should consider if it is to be correct?
4,500 plus 100.
Absolutely. 4,600 divided by?
Not divided by 5.
Yeah. And that is actually, in one of my previous sessions I had mentioned, because you're defining this as an event, then it is simply 1 minus test result incorrect. And that was 400 by 400 by 5,000. So 1 minus 400 by 5,000 is equal to 4,600 by 5,000, right? And that is what you would get from here also. Make sense?
Yes, sir. Thank you.
Okay, so next one. Next is this question. Let's see what is saying. Which of the following statements is or correct? Correlation can be interpreted as causation. Is it true? Is correlation equal to causation?
No.
It is not. It may or may not, but that means it is not. To find out the average salary of a company, the HR manager wants to use a median as the measure of average.
This is correct.
Yeah. Why is this correct? Why use median as the salary?
Because the like there are outliers, salary can vary like from person to person, so we can't take an average as the source to like the mean. We can't use that as the average.
Absolutely. Absolutely. Pie chart is the most suitable to present the numerical data. Sorry,
It can be.
numerical data.
Basically for categorical data,
Pie chart is for categorical data. Yes. So what you want to say with pie chart is that you have multiple categories, and this many people belong to this category, this many people belong to this category, this many people belong to this category, so on and so forth. So that percentage of the population or sample belonging to a particular category. So it is not true. Histogram is the most suitable to present categorical data.
It's for numerical data.
So this is correct. Yeah. So that is that. Then okay. Some of these questions are very relevant to Professor Kapil's this time, especially starting from now. Professor Kapil has a lot of conditional probability and all those things, so we can practice that after this. So we are just probably two more questions to go. The following examples have two types of data sets. Which of the examples deal with both qualitative and quantitative data sets? Okay, number of items purchased by customers in a retail store and the mode of purchase, cash, card, etc. What kind of data is this?
1 and 4.
1 and I have not gone to. Let's go step by step. What is 1? Is this quantitative?
It has both.
It has both. Okay, perfect. Prices of equities and their traded volume.
This is the
It is quantitative data only.
Yes. Gender of people along with the residential status. This is qualitative, right?
Right.
I mean, probably male, female, and if there's near the gender. Shift-wise production volume in the manufacturing plant.
Qualitative and quantitative.
Yes, absolutely. So 1 and 4. Okay. And probably the last question. I'm not sure whether there is one more question, but let's see.
But the fourth one was just quantitative, right?
Not really, because shift wise production, what happens is you can always say that this is shift is 1 to 8, which is the morning shift. And I'm just saying, 12 to 8, and then probably say 8 to whatever, I'm not sure, 5 5 to 12, and then morning, afternoon, and evening shift. So this makes it categorical, right? In terms of that, it is not quantitative in that terms. And then the volume is the, let's say 100 pieces were manufactured here, 80 here, and 20 here. Then this becomes quantitative. Clear?
Okay. Yeah.
Okay. Which of the following statement is or are wrong? Standard deviation is not affected by outliers. Yes or no?
It is affected by outliers.
Okay. Can you tell me the reason why it is affected by outliers?
Outliers will be more, then mean will increase, and mean we fetch. Mean we fetch. I mean, standard deviation we fetch from mean, right?
Okay.
So,
So yeah, I mean you are almost spot on. The thing is, mean gets your mu or or x bar sample or this thing gets affected by the outlier. So if this gets affected, then
Yeah.
obviously your x minus x bar, this equation gets affected, right? So standard
Exactly.
deviation is actually affected. So it is a wrong statement. So this qualifies. Percentiles are used to benchmark a process.
Yes.
Yes.
So it is
Yes.
true. Okay. So this is, I mean, sorry, I should say this is not false. Quartiles cannot be used to convert numerical data into categorical data.
I think it can be. It can be.
Okay. Can you give an example?
Huh?
Can you give an example?
So let's say I have values 1 to 400.
Okay.
So I want to divide into 4 quartile, right? Quartile 1 from 0 to 100, 2 from 100 to 200, 300 to 400, like this.
Sure.
So we are making it categorical, right? Oh, categorical. You are talking about the definition wise categorical.
Yeah, actually, you're almost there. So it is categorical in the sense. See, let's assume that we have a bunch of students, and those students, these guys in the first quartile is someone who scored, who failed. So your category becomes failed. These guys probably average, these guys above average, and these guys excellent, right? So that is how you convert it to a category. Clear? So this is also out of the same. What about the next one? The correlation coefficient between sales and advertising expenditure is the same as that between advertising expenditure and sales.
True.
Oh, I'm sorry. This qualifies. This was wrong in the sense that it can be used. So this qualifies as the wrong statement. This is true. So this does not qualify.
True.
If you have
It's true.
Yeah, because we saw the graph. If this is, let's say, this is the graph, and if it is a positive correlation, it is between both those two entities. Then it's strongly correlated, and if it doesn't matter whether you call this as 1 or 2, this as 2, it does not really matter. So we have got this covered. Okay, let me just see if there is any other question. There is one more question. That's a probability question. Okay, that's the expected value. I had started with expected value in some this thing. So that's a good point to start. Okay, can someone answer this question?
So, glad these
Sorry.
Multiply and add this 3.
Yeah.
Yeah. So what we do is we take, so this is 10 minus 10%. So, we multiply 0.3 into minus 0.1, then plus 0.4 into 0.05 plus 0.3 into 0.2, and this is 0.03. Sorry, this is minus 0.03 plus 0.022 plus 0.06, and that is so 3 times 3, and so this is 0.05. So it's 5% expected gain. That expected value is essentially xi into p of xi. If you do not understand this notation, please ask me. I'll explain this one. Sigma of all those things, right? So this is how you calculate the expected value. We have seen this in one of the previous classes. I think just the previous class where I explained what is expected value. And with that, the questions, probability questions are done from the test. Now, we'll probably have another.
I
Yeah.
have to memorize these formulas also.
Unfortunately, yes. Unfortunately, yes. These are though this really are very simple. What I will do is I'll tell you an example. Hopefully, you will try to if you understand that concept, then you will. If you have difficulty recalling how to calculate it, you will just remember that example and recall that example, and then you can apply this.
Just write it the formula like this, or we can directly apply
Sorry,
concept.
I don't catch your question.
In that on exam, have to write down formula like this, or we have to apply this concept only.
So you have to apply the concept. I think Professor Shovan actually, he gives you the list of formulas also. If you see the question
Oh.
that I've attached, he gives you the list of formulas you will need. So you don't have to really, you have to apply the concept. With Professor Shovan, it is not going to be that. I saw Professor Kapils. He has actually spent a lot of time in conditional probability, on which we have not really done too. I mean, we did conditional probability a lot, but you can never exhaust conditional probability questions. So all these are conditional probability questions. I was hoping to cover some of them. I'm not sure whether we'll be able to cover it. I want to cover certain important aspects of, because he has covered PMF and cumulative distribution. So I wanted to cover certain things about this from Professor Shoban so that it helps your understanding. Shall we do that, or you want me to cover something else? If there are questions, I'll do that. How do you want to spend the next half an hour?
I think by covering questions.
Sorry?
Possible for us to do a little bit of random variable if it's all right with everybody, because probability is something that we covered for the quiz, and somehow when you discussed, we were able to get clarity. I mean, like, that's for me. I would be happy to let the others choose. But is it all right if we do a little bit of random variable, because that is a little difficult to understand?
Yes, I think random variable.
Okay, let's start with random variables. So, okay. What is a random variable? I mean, we had, as I said, I covered this in the previous session once. What happens with probability is you are not able to answer certain questions. You are able to answer only few questions, right? So, for example, probability, it will rain tomorrow, and say the weather prediction is 0.6, right? But depending on this event, I want to really club this with something else. My intuition is that I want to know whether I can actually, do the seeding of my agricultural land, or I should not. If it's going to rain very, very heavy for the next 4 or 5 days, So I want to club that. I want to make an event out of it. And whenever there's an event, we define it as a random variable. It has randomness and it's a variable in the sense that you tell me what should I do if I define an event. You have some symptoms. If you're showing some symptoms, then what's the probability that you have got a certain disease? That's a random variable, right? And so, for example, I'm saying that you roll 2 dice, right? And then you have got the entire 1/36, 36 different values. 1, say like you have up to 6. Okay. And I want to say, tell me the event wherein I define X. This X I define. So X is an event I can define any which way. I can say X is defined as sum of the two is equal to say 4. So how many such X is equal to 4? Or I can say X is less than equal to 4, or P of X less than equal to say 7. So I can define various different events and I can work around that, and that is what random variable does. Okay. Now there are 2 types of random variables. One is discrete, the other is continuous. With discrete, I'm using this slide. I can use my own stuff also, but this is fantastic. Right? So discrete is something wherein you have the countable numbers. Just now the case we considered, it was a discrete function. You had only so if the sum is equal to 4, then you only have 1 3, 2 2, and 3 1 qualifying. And then what's this guy on? Okay. And now if my event is described as P of X is less than equal to say 7, then I have to consider not just 1 comma 6, 6 comma 1, 3 comma 4, 4 comma 3, 2 comma 5, and 5 comma 2, but I also have to consider P of X less than equal to 7 is equal to P of X equal to 1 plus P of X is equal to 2 plus P of X equal to 3, so on up to P of X equal to 7. This is what all qualify. And this is 0 because the 2 dice cannot have sum as 1. This will be 1. 1 upon 36, I mean. This will be something, 2 upon 36. So like this, you have to add all of these. And that is what random value probability will give you. So this is discrete. The other is it is continuous. In continuous, there's something called uncountable values in any. So infinity, there are 2 types of infinities. One is countable in infinity and the other is uncountable infinity. When you have countable infinity, that means I say all the even numbers, and you can go 2, 4, 6, 8, and that's you can count them. It's called countable infinity. Because you can map them 1 to 1, right? In uncountable infinity, anyone can. So now the obvious question would be, what is an uncountable infinity? Infinity is uncountable in any way, we know that, but you understand there is a very famous mathematical puzzle which is called the hotel with infinite rooms. You may want to look that up. How does it help? So let me give you an intuition and then I will go here. A hotel has infinite rooms and you have infinite guests, right? And now you get a new guest arriving. So how do you do that? So what you say is, you tell room number 1, you shift to room number 2, shift room number 2, you go to 3, 3, 4, so on, and you got 1 more room. And fantastic. You got 2 more guests. Then what you say is, okay, 2 you go to 4, 4 you go to 6, and so on and so forth, and you got it. So these are countable infinities. What is uncountable infinity? Can someone give me that example?
So data between a range like 1 and 2, like the continuous.
Absolutely.
if we say
That's
1.1.
uncommon. You do not know where to stop with a decimal 22/7, for example, like the pi value. You cannot the weight of a person is uncountable in infinity. It is only limited by the weighing measure we have with the capabilities that we have, but it is not limited by anything else, right? I mean, if we have an infinitely precise machine, then it will go till infinity. So that is what continuous distribution is talking about. Now, very important point here is, while we mentioned that P of in discrete, we remember this point, please. P of x is equal to 3 is an event where x is the sum of the two dice, as this defined as sum of the two dice values. This will give you some value. If it is a continuous distribution, if it is a PDF, then PDF is also for discrete, it is called PMF, probability mass function, and for continuous, it is called probability density function. In that case, probability at I'm just going to use this thing, x is equal to 3. This basically, don't get bogged down by this. It just means that at any point is equal to 0. You do not have the probability at any point is always 0 in a continuous this thing, because it is a integral. It is a integral, and integral is between a to b 2 points. And basically, let's assume those of you who understand mathematics will know that x. I mean, let's assume this is a curve. Then when I'm saying at the point, then b becomes a, and you basically minus the integral with the same two values, so it becomes 0. So in the all you have to remember is the probability at any point in a continuous function is 0. Sorry, in a continuous what do you say, probability density function, right? So that is that may be a quiz question for you, a tricky question. So now you have to find out. This is fantastic example used by Professor Chavan. A soft drink company is asking 3 people, chosen randomly, whether they like cola or juice. Based on the past experience, it is known that there is a 20% chance of liking cola over juice. Okay, so let me just copy this question and let's work out this thing. Okay, so what is P of liking cola?
0.2.
0.2. What is P of liking what is that, juice?
1 minus 0.2, 0.8.
Okay, so determine the probability distribution of the number of people liking cola. I mean, so you have, what Professor Chavan is asking is, what is the probability distribution? Now, how many people are there?
3.
3 people. Okay. So with 3, how many different values you will get?
Out of 3, maybe none of them like the cola.
Yeah. How many total values?
NC.
Nine. This is called a power set. This is 2 to the power 3. Why? Because each guy can either like or dislike, and you basically can combine any this thing. So it becomes 2 into 2 into 2 choices, which is 8 choices. So remember this, that if the number of people, if there are binary choices and the number of people, then it becomes 2 to the power of that. So there are 8 results possible. What are those 8 results? 8 results are like cola. I will start with like cola, and then I will go all the way till like juice, and like juice. Do we all agree on this distribution so far? That this is what it looks like?
Yes.
Okay. So now, here are a few important concepts. So we have 3 people, P1, P2, P3. Does the fact that P1 likes the juice or the cola, whichever, does it have any effect or any bearing on whether P2 likes the juice or the cola?
No.
They are independent.
They are independent, right? So these are independent events, right? What is the how do we figure out when two events are independent, then what really happens? Do you remember the formula? How does it change?
We basically multiply the probabilities.
Yes,
Intersection is gets multiplied.
absolutely. So P of A intersection B is simply P of A into P of B, right? So the fact that I am saying the P1 likes cola is 0.2 and P2 likes cola is again 0.2 and P3 likes cola is again 0.2. What is the probability that all three will like cola?
0.2.
Multiplied.
Okay, so follow this. The probability of that probability that the person likes the cola is 0.2. Further, because they are independent events, otherwise this would have led to conditional probability. The other person also likes the cola is 0.2 and the third person also likes the cola is 0.2 and that becomes 0.2 cube is equal to 0.08. This probability becomes top probability becomes 0.08. And then
Sir, can you repeat it? I didn't understand this.
which part?
What you just now what you
Okay.
repeated? What you said
Okay, so
in this graph?
so this is this graph, this guy is person 1. Okay, person 1 can either like the cola or not like the cola. Is that clear?
Yeah, clear.
Right? And
Yeah.
after that, when the person 1 likes the cola, then the other person can either like the cola or not like the cola. So there's a branch. And then likewise, when the other person likes the cola, the third person may like the cola or not like the cola. And
Okay.
and here the second person does not like the cola, the person prefers the juice, then the third person may either like the cola or may not like the cola. So you get 1, 2, 3, 4, 5, 6, 7, 8 such values, which is what we looked at. When I discussed it, I told that will be 8 outcomes. Okay. And because these are independent, had they been conditional, you could not have done what we are doing right now. Conditional probability, the formula changes, right? So because they are independent, so all the three liking the colas is 0.2 into 0.2 into 0.2. The third person not liking the cola is basically 0.2 into 0.2 into 0.8. Likewise, so we have covered first two persons liking the cola, but the third person either liking or not liking. Then we come back here. The second person does not like the cola, so we go from 0.2 to 0.8, 0.2 into 0.8, and then again third person liking the cola versus. Now here is the thing. Let me to further the understanding, let me try to copy paste this example and then ask you a few questions. So far, is it clear to everyone what Professor Shovan was teaching? Okay. So now we are saying that, yeah, okay. So he has covered that point also. Good. So I'm saying, what is the probability that all three like the cola?
0.2 into 0.2 into 0.2.
Absolutely. So it's 0.008. Okay. Now I'm saying two people like the cola.
0.2 into 0.2.
Into 0.8.
No. Two people liking the cola can be P1 liking the cola, P2 liking the cola, P3 not liking the cola, and P1 liking the cola, P2 not liking the cola, and P3 liking the cola, and P1 not liking the cola, P2 liking the cola, and P3 liking the cola. Right? So you have to add these together. Right? And so you get basically
3C2 into that 3C2 into 0.2 into 0.2 into 0.8.
3C2 will be equal to 3, which is not really the so those of you who do not know it, is 3C2 is equal to 3. Factorial 3 by factorial 2, and that is equal to 3, right? So 3 times you get the same probability, so the 3 into 0.032. Yeah, this is what it is. Is everyone clear about it? Any questions on this one?
So if we have a higher number, we will have to use the factorial, right?
You can use the factorial, absolutely. If you understand, if you are familiar with factorial in this thing, you can absolutely use that. I mean, that was a very fantastic take on this.
5 people.
Mm-hmm.
How would we do it?
First of all, if with 5 people, how many cases you will get?
5C2.
No.
5 power 2 के power 5, so 32.
Yeah, you will get 32 such cases, and then you have to, once you have figured out all the 32 cases, after that you apply the 5C2 and all those things. I mean, like 5C3, 5C2, whatever you want to apply. So it gets applied over there. Yeah.
Okay.
Sir, one question.
Yeah.
When we do this 2 raised to 5, like I remember in my like engineering, we used to do probability there. Sometimes we use this 2 raised to 2 raised to 5. If there are total number 5, then 2 raised to 5. If total number 3, then 2 raised to 3. When we use this.
Is your question, when do we use it?
Yes, when do we?
Okay. See, the thing is, if you are saying that if a person can choose to do something true or false, right, or heads or tails, right? Basically, there are 2 outcomes. Okay.
Okay.
And number of such people are, let's say, n. Okay. Then you will get 2 to the power of n outcomes. Why? Because it's like, if you remember the bits, how the bits are calculated, right? So in a byte, that is what it is. So this guy is so you get basically you get 0 0, you get 0 1, you get 1 0, you get 1 1. So with 2 you get 2 to the power of 2 is equal to 4 is equal to such sets. With 2 cube is equal to 8 is equal to, you get
Got it, sir.
understood, right?
Yeah, yes.
And if you have 3 outcomes, just one more point. If you have, let's say, 5 outcomes could be that could be anything. I don't care what the 5 outcomes are. And you have n such people, then you will get 5 to the power of n outcomes. That's it. That's as simple as that. Yeah.
Yeah.
Okay. So where were we? We were here. Okay. So now I'm saying, just give me a second. P of x to the power of 3. Sorry, x equal to 1. That means we are saying one person likes it, right? And what will that be?
3C1 and 2.
3C1.
That is
Absolutely.
also 3.
No, 3C1 is 1.
No, 3C1 is 3.
So it's 3. I'm so sorry. Yes, 3C1 is 3. Yeah. So 3 into points, whatever it is, point
0.2 and then 0.1.
0.128. Yeah. So that is that, right? So yeah. So now I'm saying P is equal to x less than equal to 2. Then what will you do?
We'll use 0, 1, and 2.
Yes. So you will use P of x equal to 0 plus P of x equal to
And add on.
plus P of x equal to 2. Yeah. Clear with this example? Is this concept clear?
Yes, sir. Yeah.
I will forward you a joke and which is going around in Oxford University that please stop calling sirs and ma'ams. Anyway, okay, so let's get back to this thing. We have very less time. Are you guys fatigued or can we go on for 10 more minutes?
We can go. We can go.
Okay, so now where is this? Yeah. Okay, so that is random variable and probability distribution. So we calculated the probability distribution given certain problem statement, right? We saw that. The cumulative probability, what I did just now here, this is cumulative probability part. Basically, what I'm saying here is that if you add the probabilities of events in such a way that you add them up, then they will all become 1. So we have P of x equal to 0, basically meaning this is no one likes the drink, right? No one likes cola. And that would be probably this one. So that is equal to 0.8 into 0.8 into 0.8, which is 0.512. Then I'm not saying P of x equal to 1. I'm saying less than equal to 1. Because it will include 0 as well as 1. Correct? And so I have to include the probability that one person likes it, this one, and it will become 0.512 plus 0.384, 6 and 9 and 8. So it becomes 0.896. And then I will say P of x less than equal to 2. You see, I'm making it cumulative, right? No person likes it, at least one person likes it, at least 2% like it, right? So this becomes this sum 0.896 plus at least 2 is what? This 0.096. This is 2 and this is at least 2, at least less than equal to 1. So this becomes 12, 1 and 18,
1.856.
1 point cannot be.
Okay.
Okay. And then last is P of x less than equal to 3, and that is 0.992 plus the last one, which is only 0.008,
1.
and this becomes 1. So the cumulative probability always takes you from whatever initial value to 1. Clear? So this is what it says, that the sum of the probabilities equal 1. The sum of the probability is also 1, but the cumulative probability will take you to 1. And okay. Then again, the same thing has happened here. In the PMF, you have number of customers as 80 who have 0 cards, 50 who have 1 card, 40 who have 2 cards, 10 who have 3, and 20 who have 4. So the probability basically is 80 divided by 200 becomes the probability for the person who are holding 0 cards. 80 divided by 200 is basically 40 divided by 100, so it is 0.4. Is this part clear? Any questions, anyone? No? Yes? 50 divided by 200 is 0.25. 40 divided by 200 is 0.2. So likewise, so you have calculated the probabilities, right? Now can someone tell me with this, this is the cardholder sequence. Now can someone tell me what is the cumulative probability? How do we calculate this? So 0 cards, what's the probability?
0.4.
At least 1 card.
0.4 plus
0.6.
0.2.
Yes.
0.65. 0.65.
At least 2 cards.
0.85.
0.85.
At least 3.
0.9.
0.9.
And at least 4.
1.
1.
Is this concept clear now?
Yes.
So, and this is the basically the graphic representation of PMF. I think we will probably stop. Okay, oh no, this is a fantastic. I see some people have dropped off, so I don't want to kind of. This is a fantastic question. I saw this question. Lovely. How do you find K? Okay, and we'll not solve it, but tell me just the idea behind how do you find K? A random variable has the following probability distribution: 0, 1, 2, 0 till 8, and then you have K, 2K, 4K, 6K, and 16K. You have to find K. How will you find it?
The above answer probability equals to 1.
Absolutely. So K plus 2K plus 4K plus 6K plus 8K, so on, will become equal to 1, and you will find K. And then you can find all these cumulative probabilities. Clear?
Yes. And one question here,
Yeah.
like for the cumulative probability, we are basically taking the range and we are adding, right?
Mhm.
But what is PMF? It is like a single value at a particular point.
No. Probability mass function basically, okay. So statistics has this weird habit of doing few things which are really, really torturous for someone who is not doing a master's in statistics. I'll tell you the reason why. You have seen. Okay. What's the formula for mean?
Like
No,
sum of
let her reply.
upon number of observations.
Divided by n.
Okay, so you have total divided by number. How do you represent this? Mu is for the
If it's
population.
population, it's for population mu, and for sample it's x bar.
Absolutely. Okay, so even though they both almost mean the same thing, we represent different formulas. So PMF is actually coming from, this is PMF says that a probability mass function because it uses certain concept of gravity, center of gravity, and all those things. PMF is almost equal to PDF in almost all respects. I mean, don't even think of what my suggestion. What I'm trying to say here is, in the exam, you will not care whether you write mu or x bar. I mean, to calculate something. Yeah, the formula may differ from somewhere. There will be 1 by n minus 1 instead of 1 by n. If you are doing the variance and all those things, that's a different thing. But you will not. This is called probability density function because there is actually there is something called derivatives used to do something, but that has got nothing to do with the fact that how your probability looks like. So this is discrete and it just says, okay, you know what? Show me the center of gravity of this entire distribution. That's why it is called probability mass function. It is nothing to do with anything else. Just treat it for all practical purposes, PMF and PDF. In your mind for your course, consider that they are just names, nothing else, nothing more to it.
So just one is for the discrete and other is for
Absolutely.
the continuous.
Absolutely. This and PMF is for discrete and PDF is for the continuous, and the cumulative is relevant to both of these. Even for continuous, the cumulative will add up to 1, and even here it will add up to 1. Yeah. All right. Any other questions for today?
No, just a request.
Yeah.
Share this recording.
I will. This will take about 3 or 4 hours. I will share it. Not to worry.
Yeah. Thank you. Thank you so much.
No worries.
That's all. Thanks for giving your time.
Hey, no worries. All right.
So what you do, Anupro? What you do?
What do I do? I am looking to come back into IT. I have a sweet shop in Bhopal, and I am hunting for a job. So that's what I'm doing.
Oh.
Yeah.
Okay. So you have like any IT experience? Or
I'm complete. I have 22 years of IT experience and completely. I'm very technically hands-on person. So, and I am in AI/ML and data analytics primarily.
Okay, data analytics you have, right?
Yeah.
Okay, I'll talk to you.
Sure. Yeah. Cool.
These calls are on.
Yeah.
Thank you.
All right.
Thank you.
Take care.
you.
Yep.
Thanks a lot.
Yep. Bye.
Thank you.
All right. Good night.
Good night.
Good night.
Good night all.